Alright, chapter 4.4 is about imaginary numbers. You've worked with square roots in your algebra experience. We know that the square root of 4 is 2 because we know that 2 times 2 equals 4. But what makes the following problem true of the square root of negative 9? Well, you can try 3, you can try negative 3. I think those are the only numbers that multiply to make 9. But again, we know the answer is not 3 because 3 times 3 is 9, and our first instinct when we see this is to say negative 3 because it's a negative. But if you analyze further, a negative times a negative is actually still a positive 9. So if both versions of 3 lead to a positive 9, then what value of 3 would lead to a negative 9? Again, we know it's got to be a 3 because that's the only number that leads to a 9, but how do we make it negative? Well, someone at some point, some mathematician came up with the idea to make this problem work, at least workable. They decided to define a value as the square root of negative 1. And if we can implement this, then it fixes all of our issues, because what we can say is that the square root of 9 is equal to the square root of 1 times the square root of 9, because of course if you remember it's inside times inside, and that makes negative 9, which then allows us to turn this into a 3 times the square root of negative 1. Alright, but of course we don't want to write it that way because the square root of negative 1 is still an ugly number and it still shows that square root. So what they decided to do is label the square root of negative 1 as I. And I in this math is our mathematical symbol for what we call an imaginary number, and we use the word imaginary because we know the square root of negative 1 actually does not exist. So again, an imaginary number is a number that is a negative under a root. It's denoted as I because it is, again, imaginary, and that should be of I, but of course that's always good to make a mistake on a video. Extending the powers of I, one of the most important characteristics of I is that it can be taken to many different powers. The cycle of values repeats for every 4 values. Here is the brief summary that must be memorized. I itself, of course, is the square root of negative 1. If I take the square root of negative 1 times the square root of negative 1, then of course what happens is the square root goes away, giving us negative 1. I to the third is the same as I squared times I, which means that you have I times negative 1, which is why you get the answer of negative I. And I to the fourth is the same as I squared times I squared, which of course negative 1 times negative 1 gives us the answer of 1. So this pattern can be extended to much larger powers. You just have to recognize the pattern. It's a very simple pattern. This again is I to the first, I to the second, I to the third, and I to the fourth. The pattern exists because anytime you have something that repeats a certain number of times, you can actually use division to determine what's going on. And again, the first number will always be if the remainder is 1. Because let's think about this. What is 1 divided by 4? It of course is 0.25, which 0.25 means if we turn that into a fraction, it's 1/4. So 1 is left over out of 4. I to the second. So if I did 2 divided by 4, notice you get 0.5 because 2 of those is what's left over. 3 divided by 4, of course, is 0.75. Again, 0.75 meaning that there are 3/4 left over. And 4 divided by 4 is a clean number, which is there. So again, the reason that 4 is not a remainder is because if there are 4 things in the pattern, then you can use that as your number. So again, anytime you get no remainder, it's this one. Anytime you get a remainder of 3, it's this one. Anytime you get a remainder of 2, it's here. Anytime you get a remainder of 1, it's here. Again, the nice thing is you're dividing by 4, which means that you can easily see 0.25 is 1, 0.50 is 2, 0.75 is 3. So if you wanted to know what I to the 3/20th is, you just have to do 320 divided by 4 because there are 4 different values that repeat. Take your remainder, of course. 320 divided by 4 is 80. That means the remainder is 0, which means your answer is 1. Again, you might want to put that down and make sure you understand what's going on. If I was to ask what I to the 471st is, I would do 471 divided by 4, which is 117.75. So 471 divided by 4 is 117.75. That means that my remainder is 3, because remember it breaks into quarters. And because my remainder is 3, it's going to be the same as I to the third, which means my answer is negative I. This is why you have to memorize them, because if you do not memorize them, then it's going to be hard to do this on a test. 214 divided by 4 is 53.5. That means that my remainder is 2, because of course 2/4 make a 0.5. The 2 means it's I squared, which means my answer here is negative 1. and I'm pretty sure you can assume what 97 is. So 97 divided by 4 is 24.25. That means that my remainder is 1, and because my remainder is 1, I am looking at the first version of I, which is just I. So again, whenever you see that, just make sure you do that and knock out that information, because again, it's not that bad to do once you understand what's going on. Make sure you practice that, and once you have it down, I don't think you can mess it up too much after that. Again, be sure to study this pattern. There's really no other way except the old-fashioned way of counting through, which is, if you wanted to know what I to the 576 was just to go through 1, 2, 3, 4, 1, 2, 3, 4, and keep going. So again, the pattern of dividing and using the remainder is probably the best and most efficient way to do it. I have not learned another one, and when I do, I will add it to my lessons, I promise. Algebra and I. That is not a statement about algebra and me, but I'm saying algebra with I. When working with the variable I, we just treat it like any other variable in algebra. There is one rule that must be respected at all times, and it's that I should never have an exponent. Look back at what we had here. Even I to the 3/20th turned into a number. I to the 4/71st turned into a version of I, which is negative. I to the 2/14th turned into a negative number. I to the 97th turned into I. I squared turns into a number. I to the 3rd turns into an I to the 4th turns into a number. So at no point, if you're dealing with I, an actual imaginary number, should you ever have anything with I going to a power. And as long as you respect that and simplify everything, you will be fine. The examples that you have are pretty simple. The mistake they expect you to make is very basic, and hopefully you do not make it. The mistake that people make is they see a parentheses and a parentheses, and because of this one they want to multiply. But don't forget, this is telling me that I need to subtract. But we should have learned by this point that the best thing to do is to write it without the parentheses, and then combine your terms. This is 5, this is minus 4i, and that is as far as you can go. Again, the issue is going to be for anybody who's going to be stubborn or try to rush when they don't rewrite it and they get 5 minus 8i because they don't view that. Or a shortcut that you could possibly use on a test, on any test, especially whenever there are negatives, is to switch this, and then kind of like we did with elimination, switch both things on the inside. Now you see a 9 and a negative 4, you see a negative 6 and a positive 2. Either one of those works, but again, whatever you use as your style, just make sure you practice it, make sure you master it, and everything should be fine. The other thing you want to be able to do is the distributive property. I know you call it FOIL, but that's not really what I like to teach. 7 times 6 being 42, 7 times negative 3i is negative 21i. This makes a positive 6i, and this makes a negative 3i squared. Simplifying this further, we get 42 minus 15i minus 3i squared. I don't think that's visible, which is not good. So again, 42 minus 15i minus 3i squared. The problem here is that you cannot have an exponent on I, and so we must look at I squared and recognize that I squared is the same as negative 1. And so what you end up with is 3i squared, negative 3i squared. If this is a negative 3 and that's a negative 1, it just turns into its opposite, which is that. Again, I squared is negative 1. Negative 1 combining with a negative 3 is going to make it a positive 3, which now gives me a like term, 45 minus 15i, which is what you're looking at. Alright? So again, the trick here whenever you do that is to make sure that if you have an I squared, you simply have to change it. So if I ever saw plus 4i squared, it would simply, because this is a negative 1, turn that into a negative 4. If I had negative 7i squared, the I squared would simply turn into a plus 7. So again, it's not hard to do. It's just something you need to practice, something you need to make sure you get down. And once you have it down, I think you'll be fine. Simplifying radicals with I, which I believe is the last section you have on this, which is probably the one that you're not going to like at all, but you'll be fine. First of all, I'm not going to assume you remember the process of simplifying radicals. That's not what I'm here to do. I'm here to teach you. So let's look at some examples from your experience with Algebra 1. We learned that the square root of 50 is not simplified because there is a perfect square in there that can be taken out. For example, if I was to do the prime factorization of 50, you would actually have 2 times 25 which is 5 times 5, which means it's actually the square root of 2 times 5 times 5, which automatically tells you that there is a number in there that is repeated in a square root so something can come out. That is a fine way to do it if you want to do the prime factorization way, but I told you to memorize 5 numbers, 4, 9, 25, 49, and 121. You typically don't use the 121, but they come from the first 5 prime numbers that we have in squaring them. 4 does not go into 50, but 4 does not go into 50. Just check the numbers with the actual value. 4 doesn't go, 9 doesn't go. 25 times 2. This is under a root, which means that 25 comes out as a 5. I'll circle that number. It comes out as a 5, and then the 2 just stays in there, giving us this answer. Now here's what you can do to check it. You can do square root of 50, and then you can do 5 square root of 2, and the reason I know these are the same is because it's the same exact value. So again, the value did not change, we just gave it a facelift. It looks different, that's all. Square root of 98, 4 does not go into 98. You can check if you want. 98 divided by 4, nope. 98 divided by 9, nope. 98 divided by 25, nope. 98 divided by 49, yes, that's 49 times 2. So again, this turns into 49 times 2. This number under a root turns into a 7 root 2, and again you can check that by doing square root of 98 equals and 7 root 2 equals, and you notice you get the same answer in both. Square root of 48, I believe 4 goes into 48 12 times. The only reason why I could stop in the other ones was because 2 can't be broken down, but 12 actually can. This is also 4 times 3, which means what you have out here is a 2 times another 2 with a 3 on the inside. This of course turns into 4 root 3. You can check your numbers. Square root of 48, 4 root 3, same answer, same value. You got it. Again, 162, I don't think it goes into 4. 162, I don't believe, actually it does go into 9. Is 18, so it is 9 times 18. Again, that's a perfect square. 18 is also 9 times 2, which is a perfect square, so we end up with 3, and another 3 coming out with a 2 on the inside. 3 times 3 makes 9 root 2, which again I'm not going to check, but that is what it is. The beauty of this calculator here, which is another reason why you don't get to use it on this test, is because if I were to type the square root of 50, look what it does for me. If I were to type the square root of 98, square root of 98. Look what it does for me. So the reason why I told you that you should buy this calculator is because it's not as expensive. Again, it's only $15. TI-30XS Multi-View. It's only $15, $16. I think I saw it at Best Buy for $16, but I've even seen it as low as $12 at sometimes on sale. But it does all that, and it actually makes your life easier and other things that people don't like. So we also learned that multiplying radicals is as simple as inside times inside, outside times outside. So again, moving on with this, we're looking at this, and at some point in algebra you did learn that you're supposed to do 3 times 5, which is 15, root 2 times 3, which is 6. Now you do always have to check. Does 4 go into 6? Nope. Does 9 go into 6? It's too big, so we're fine. That is why I memorized the 4, 9, 25, 49, because prime factorization takes a while and you're still not guaranteed to get anything out of that number. Here we go. 6 and 5 make 30. 3 and 6 make 18. Real quick check. Does 4 go into 18? No. Does 9 go into 18? Yes. It turns into 9 times 2, which means that this comes out. Now here's where you need to be careful, because 30 is already out there. A 3 came out and a 2 stayed in. That gives me 90 root 2. Let me see if zooming helps you see this a little better. I'm sorry. Maybe a little bit. But again, 90 root 2 is what we're looking at. And here's the beauty of, again, calculator programming. If you want to learn how to do this, simply open up parentheses, do 6 root 3. Notice when I did that a parentheses opens up, so close twice, because that puts this whole thing in one set. Parentheses, because your calculator knows it's being multiplied. 5 root 6. I don't really need to close this because it already recognizes this as one group, and we get this answer. Then I can do 90 root 2 and hope I get the same answer, and we do, which means that everything is where it needs to be. Square root of 18, square root of 20. I would suggest that you don't multiply first because that gives you a big number. What I would do is break this number down to 9 times 2, which is 3 root 2. Break this number down, which is 4 times 5, or 2 root 5. And then in the end, you end up with 6 root 10. Now again, you could have easily did 18 times 20 because they're both on the inside. And then you could have broke down 360 by seeing it 4 times whatever, 9 times whatever, and then broke it out from there. Either one of those ways works, but I will give you the advice for I's that you want to make sure you simplify before multiplying. Again, it seems like a really silly step, but it does lead to an incorrect answer. I actually had to check one of my answers twice with the book just to find out I did it wrong, because my natural instincts were to multiply first and simplify second. So bringing in the I's, square root of negative 90 means that what you want to do is turn this into I root 90 first. Then break out your 90. So you have 9 times 10, which is I already out there, 3 coming out, 10 staying on the inside. And we of course know that when we treat I like a variable, it's just like this. We do not put I in front of a number. 3I root 10. You cannot check the I portion. You can at least check the 90 portion. 3 root 10 and square root of 90. At least that way you can make sure you got that number right, because the I portion shouldn't be that bad. Here is where it comes in. If you were to multiply this times that, you would get the square root of, I don't know, I think 90. Negative 6 times negative 15 is 90 positive, and then you would do the square root of 90 and break it out. Notice that you had the square root of 90, which means that you think that it's a positive 90, but here's the issue. If we were to simplify first I root 6, I root 15, then we multiplied I times I is I squared root 90. We then break 90 down the same way as usual, bringing out I squared, bringing out 3, leaving 10 on the inside. That gives us 3I squared root 10. But the problem with that is, remember I said that you cannot leave I with a number. I squared has the same value as negative 1 if you remember. And if you remember, what I said also is that anytime you have I squared attached to a number, simply switch the sign on that number. And that is where you would have missed it. Because if you were to do the square root of 90 from where it was, you would have just got 3 root 10 and stopped. But it's actually negative 3 root 10, and you need to be careful about that. All right. And then the last question before we wrap this up, 2I squared root 3 times 3I root 6. Outside times outside is going to be 6I to the third root 18. I would simplify this first as 9 times 2. That turns into 6I to the third times 3 root 2, which of course makes 18I to the third root 2. Going through our parts, I is just I. I squared is negative 1. I to the third, if you remember, is negative I, which means that this turns into a negative I, and because it's negative, it means that the 18 is going to be negative, that the I to the third turns into a regular I. Again, it's negative I, so this turns into a negative I, which again makes that negative and brings out I, leaving the 2 as your answer, and there we are. So again, get some practice on this. I know it's a short day, but you do have a full day tomorrow to kind of get practice on the whole chapter before we take the quiz. So again, make the most out of the day today. Make the most out of tomorrow. Make sure you ask as many questions as you can. Your quiz, your second quiz for the chapter for the quarter is again on Friday, so you do want to make sure you're ready for that. Other than that, go ahead and get some practice. Again, start asking the questions you need, and good luck.